right. Hello, year 12. Hope you're doing well. Um, I'm not doing too well, but it's okay. Good to see you all. Yeah, give me those views. All right, let's start with a joke. How do you make a sausage roll? You push it. Oh gosh. All right. What am I doing here? Let me get this up and going. Share screen. All right. So we've been doing differentiation with respect to time. Today we're going to do integration with respect to time. So a couple things that we need to know is you're going to get used to seeing this. All right, if I go from x to x dot to x double dot, which means displacement to velocity to acceleration, I do that by differentiating. So if I go the other way, it makes sense that I'm going to integrate. Okay, so the order is kind of important. And we're going to be integrating with respect to time. So it's going to be dt. Okay. Now, the other thing is when you integrate, sometimes there's a plus c. And so what I've written down here is they'll often, not always, but they'll often give you initial conditions. And that's just a fancy way of they'll give you enough information for you to find out whatever the plus c is when you integrate. Okay, because we're talking about real world now. So that means we can't have this random plus c. We kind of need to have, we kind of need to know what it is. So we've just got one question today, so you can kind of see what it looks like. Okay, so we've got, it says here, particle acceleration is given by a equals 24t. Initially, the particle is at the origin, moving 12 meters per second to the left. Okay, find the function for velocity. Now, all you need to know here is there is a lot of information here. Okay, this is important. That's where you start with. Now, initial, what does initial mean? Hopefully you remember, that means initial is when time equals 2. I hope some of you guys said in class, otherwise it would have been this awkward like silence. Okay, the particle is at the origin. Origin means what? Hopefully displacement is at 0. If you didn't say 0, unlucky. Okay, and it's also moving 12 meters to the left. So what that means is that's negative 12. That means velocity is negative 12 meters per second. Okay, so because we're traveling to the left, that means we're going to have a negative velocity. The speed is going to be 12 meters per second, but because we're traveling to the left, velocity is negative 12 meters per second. Okay, now we want to find a function for velocity. So I don't want to know, most people would just look, okay, well, it's 12 meters per second or negative 12 meters per second, but that's not the function. That's just what it is initially at one point in time. I want to know what it is over basically all the time. So what happens here is we've got acceleration and I want to find velocity. So how do I get from displacement, velocity, acceleration? I'm at acceleration and I want to get to velocity. So I'm going to have to integrate. Okay. That's what I'm going to have to do. So I'm going to go integration of 24t dt. That's it. And so if I integrate that, hopefully you remember how to integrate, this will become 24t squared over 2. And that becomes, oh, I should probably say plus c. And then cleaning that up, this becomes 12t squared plus c. Now, again, I need to find what that plus c is. I can't just leave it as a bit of a random. So what I'm going to use is, I know initially the particle was moving at 12 meters per second. Okay, so I'm going to move this around a little bit. So I've got a little bit of room. And so just note here that what it's trying to say here is that at t equals 0 initially, right? At t equals 0, my velocity was negative 12. So this here is my velocity. So I'm just going to replace that. So negative 12 is going to be 12. And when time equals 0, it's 12 times 0 plus c. And so we can see here that 12 times 0 is 0. C equals to minus 12. So now just to finish things off, I can give you a equation for my velocity is going to be 12t squared. Instead of writing plus c, I'm going to write minus 12. And that's it. That would be my velocity. Yep, there's my function. Okay, now from here, find the function for displacement. Now, that's what we're going to do. Again, d, v, a. I went from a to v already. Now I'm going from v to displacement, from velocity to displacement. So again, I'm going to integrate. So now this time I'm going to integrate my velocity, which is 12t squared minus 12 dt. Okay, hopefully this is a nice integration. This becomes 12t cubed on 3 minus 12t plus c. Okay, now again, we need to know what that plus c is because I want to find the function. Plus c is not good enough for me. I've got high expectations and high, whatever. And then what we've got here is we've got initially, we know the particle is at the origin. Okay, so initially particles at origin. So that means initially t equals 0, particles at origin. That means displacement equals to 0. Okay, done. So let's just figure this out now. So when d equals 0, I'm going to substitute d in here. I also know that time is also going to equal to 0. So it's going to be 12 on 3 times 0 cubed minus 12 times 0 plus c. Now that's nice. That's going to turn to 0. That's also going to turn to 0. That's 0. Surprise. C is going to equal to 0 here. So at least now I can say with confidence, my displacement here is just going to be 12. Simplify that a bit. 12 on 3 is the same as 4. So I've got 4t cubed minus 12t, and that there is my displacement. Now again, if I just wanted to double check, there's my displacement. Let's go to velocity. If I differentiate, that'll give me 12t squared minus 12. And then do it one more time, differentiate one more time to get acceleration. I get 24t. And that's exactly what we started with. Everything checks out, and we also fulfill our initial conditions. So yeah, that's that. All the other stuff should be from the last lesson as well, talking about at rest or initial or all these kinds of things. The only difference now is we're going to integrate to go backwards sometimes. So have a go at those questions and all the best, and I'll see you guys soon. All right, bye-bye.